Good morning. Today we're going to talk about representing a quadratic function in vertex form. So the vertex form of a quadratic function is given to us as f of x equals a times a quantity x minus h squared plus k. And it's called vertex form because when it's written like this, we see the vertex and they are the h and k value in our given problem. Okay? And it also is worthy to note the standard form of a quadratic function is seen here. But we're going to talk more about that later. And it's also important to remember that the original parent parabola y equals x squared is a parabola that's a U-shape opening upwards. Right? And the vertex is either the highest or lowest point on the parabola. Now this vertex form should look somewhat familiar to the things that we were discussing in section 1-2, which was transformations. If we remember in transformations, multiplying the function by a value, by a negative value, reflected the graph. So the value of a, if it's positive or negative, determines whether it opens up or down. And if you multiply it by a number, that determines whether it's stretched or compressed. Right? If you multiply by a fraction, it'll be compressed. If you multiply by a number larger than 1, it's stretched. And then the h value inside the parentheses with x is a horizontal translation, and the value outside the k represents the vertical translation, whether it's up or down. So, in this problem, we want to identify the vertex, axis of symmetry, min, max, domain, and range of this function. So the first thing I do is compare it to the standard form, which is given there. Now, if I compare it, I notice that the signs are opposite. So here, my h and my k aren't going to be 4 and 5. They're going to be -4 and -5 because those signs are opposite. And I also know my a value here is a -1. And now this is important because it tells me that the graph opens downwards. And also my h and my k value tell me that it shifted to the left 4 and down 5. So my parabola is something like that on the coordinate plane. So I know my vertex is -4, -5. And because it's opening downwards and I know my vertex, I know that my graph has a maximum. Because it opens downward, it has a maximum. In this case, it does not have a minimum. But the case would be reversed if it opened upwards. It would have a minimum, but no maximum. So here, I know I have a maximum, and the maximum value is the maximum y value. So here, my function reaches -5 as the highest y value that it ever touches. Now, the domain of a parabola, because it stretches left and right forever, is going to be all real numbers written in interval notation. We say from -infinity to +infinity. And because I knew that it has a maximum at -5, I also know the range. Since it's opening downwards, it starts at -infinity and it goes up until -5, and that point is included because it's the vertex on the parabola. So I didn't really do anything math-wise besides interpreting the information that was given to me. I knew the vertex from identifying what was in place of h and k in the standard vertex form, and I also realized that a of -1 makes it open downwards, which tells me I have a maximum, and it tells me how to find the range. Now, you might also be asked to find the equation of a quadratic function. So here, they're going to give you a vertex and a point. So the steps are that we first plug in the h and k value into our function, and then we plug in the x and the y. Now here they told you that you only had a y-intercept, so it seems like they're not giving you an x and a y, but you have to remember that the y-intercept has an x value of 0 because it's on the y-axis. So here I have the point 0, -1, and if you plug in that x, that y, and you're given an h and k, you can find a value for a, and to write the equation of the parabola, you're substituting in the values for a, h, and k into the vertex form, and that's how you're getting your final answer. So let's try one. We want to know the equation of a parabola with a vertex 1, -4, and passes through the point -2, -1. So the first thing I have to do is recall the vertex form. And then remember that I'm given my h and my k, and I'm given an x and a y. So if I substitute in those values, I get -1, because remember, f of x is essentially y, equals my a value, I don't know, that's what I'm trying to find. That's my one unknown. My x that was given was -2. My h was subtracting 1. And the k was -4. So I should write -4 instead of -k. And now here I can solve this problem for a. So simplifying this, -1 equals, here I have -3 squared, which becomes 9 times a minus 4. If I add 4 to both sides, I'm going to get +3 equals 9 divided by a, or 9 times a. To solve for a, we're going to divide both sides by 9, and we get that a is 3/9, but we can simplify that and say 1/3. And now that I have my a, h, and k, my final answer is to just substitute those values in. To vertex form. Now you may also be asked to do this, but the information is given to you in the form of a graph. So here we're given a graph that shows the height of a flying disk with respect to time, and we want to know the equation of the function. So same thing, I'm given an x and a y and an h and a k. I need to substitute those values into the vertex form, which again is y equals a times x minus h squared plus k. Substituting in those values, I get 4 equals a, which I still want to find. My x was 0, my h was 2, plus k, which was 10. Solving for a, I get 4 equals -2 squared gives me 4a plus 10. We're going to subtract 10 from both sides and get -6 equals 4 times a. And if we divide both sides by 4, we'll get a is equal to -6/4, or we can say -3/2 once we've simplified it. So my equation is going to be y equals -3/2 x minus 2 squared plus 10. Now this is, again, in vertex form, and they want it written in the form of ax squared plus bx plus c. So what we have to do is we have to take this from vertex to standard, and the way we do that is by simplifying the given vertex form. So that means we'll have to FOIL out x minus 2 squared and combine like terms. So rewriting the problem down here, I have my vertex form, and instead of writing squared, I'm just going to expand this because squared just means times itself twice. So I can rewrite my given problem. Instead of saying x minus 2 squared, just say x minus 2 times x minus 2. The first thing I'm going to do is FOIL this together. So you can think of it as first to outer and inner and last. Or you can think of it as distributing the x to both terms in the second set of parentheses and the 2 to both terms. And that's going to get us y equals negative 3/2 x squared minus 2x minus 2x plus 4 plus 10. Then I can combine like terms inside the parentheses. And that becomes minus 4x plus 4 plus 10. And while this work may seem daunting, it's really just keeping an accurate record. We're only doing a simple step between each of these steps. The problem itself is just a long problem, and it has a few terms in it. But the first step, we just FOILed the parentheses out. The second step, I combined like terms. The third step, I'm going to distribute this into my parentheses. Now remember, when you're multiplying a whole number into a fraction, it just multiplies into the numerator, because anything is a fraction over 1. So now I get y equals negative 3/2 x squared plus 12 over 2x minus 12 over 2 plus 10, which, if I combine like terms and simplify where I can, the 12 divided by 2 just becomes 6's, and my final answer is negative 3/2 x squared plus 6x. Negative 6 plus 10 is going to give me positive 4. And that is my final answer. And the equations are equal. The vertex form is the same equation and same graph as the vertex form. It's just rewritten where we expanded the x minus 2 squared, distributed the negative 3/2, and combined like